Welcome back, everyone, to another deep dive. We've got a super interesting paper to dig into today, all about a new way to train those vision language models, VLMs, using something called a multimodal textbook.
Right.
Yeah. I know when I first saw that title, I was like, wait, textbooks AI? What's going on here?
Yeah, it sounds a little counterintuitive at first.
Yeah.
But it's actually a really clever approach.
So maybe we can start with, what's the problem they're trying to solve?
So the basic issue is that a lot of the existing VLM to data sets, especially the ones that try to combine images and text, they don't really capture the structure of how we learn, from a real textbook, right? Think about it you're trying to learn physics from just a random web page with pictures scattered all over the place.
Right.
It's not going to be very effective.
Not ideal.
You need that clear progression of ideas, the supporting visuals, a logical structure to really grasp those complex concepts.
Makes sense. So this multimodal textbook idea, how does it address that?
Well, they've basically tapped into the world of online courses. Those are already structured like a learning experience.
Yeah.
And they've created a data set that's basically like a textbook, but it's built from these instructional videos.
Oh, yeah.
So it's using things like keyframes from the videos, transcripts of what the instructors are saying, and even the text and formulas that are displayed on screen.
Okay.
It's all woven together to kind of mimic how we learn in a classroom.
Oh, that's so interesting. So instead of training VLMs on just random images and captions,
right,
now we're giving them structured lessons from actual courses. That's
right. It is like a way more organized way of teaching them.
Okay. And what kind of impact does that have on the VLMs? I mean, we already know VLMs are capable of doing some pretty amazing things, right?
Yeah, they are. I mean, they can understand images, answer questions, generate captions, all sorts of things.
Right.
But just imagine what they could do if their training process was more aligned with how humans actually learn.
Okay, yeah, I'm seeing the potential here.
Yeah.
So walk me through how they actually built this multimodal textbook. I mean, where do you even begin with something like that?
Well, it's a pretty involved process. They started with this massive collection of 75,000 instructional videos.
Whoa.
Yeah, it's over 22,000 hours of class time.
Okay, that's a lot of videos.
It took almost 3 years of nonstop lectures.
Yeah, that is a ton.
But they didn't just dump every educational video they could find into the mix.
Okay, so there was some strategy involved.
Oh, yeah. Very strategic. They used a large language model, an LLM,
right,
to create what they call a taxonomy.
Huh?
Think of it like a super detailed table of contents for all this knowledge.
Okay.
It covers 6 major subjects. So you've got math, physics, chemistry, earth science, engineering, and computer science.
Gotcha.
And then within each subject, they've got specific courses. And even within those courses, they've identified 3,915 unique knowledge points.
Wow, it's like they created a whole curriculum for AI school.
Kind of, yeah.
So how did they make sure they were pulling in high-quality videos?
Yeah.
Not just, random clips pretending to be educational.
Right. They use this really cool multi-level filtering system. It gets more and more refined as it goes along.
Okay, I like that. So walk me through it.
All right. So the first step is what they call video level filtering.
Video level?
Yeah. So an LLM actually analyzes the video title, the description comments, even a transcript of what's being said.
Oh, wow.
And it weeds out anything that's irrelevant, like ads or videos that aren't actually instructional.
Okay, so they're making sure the AI isn't getting its physics knowledge from a 30-second watermelon drop video or something.
Exactly. Yeah, got to keep it high quality.
Okay, so what happens to the videos that make it past this first filter?
Those get broken down into shorter segments based on the timestamps from the transcript.
Okay.
And that's where the clip level filtering comes in.
Clip level filtering, what do they look for at that stage?
So at this point, they want to make sure that each clip has enough visual information. No boring talking heads allowed. Okay. They use an AI to analyze the visuals and make sure they're actually relevant to what's being taught.
So it's got to be more than someone just explaining a concept. You need to see experiments, diagrams, demonstrations, that sort of thing.
Exactly. Even if the transcript has great information, if the clip doesn't pass this visual test, it's out.
Wow, they're serious about this multimodal thing.
Yeah, they're really committed to making sure the data set is strong on both the visuals and the text.
Makes sense. So we've got the video level and the clip level. What's the final stage in this data refinement?
The final stage zooms in on the keyframes, those standout frames within each clip.
Okay.
They use an algorithm called SSIM, which basically looks for significant visual changes between the frames.
So if there's a sudden zoom in on a diagram or like a new equation pops up on the screen, those would be considered keyframes.
Yeah, exactly.
Got it.
It's all about making sure that each piece of visual data is packed with information and not just redundant filler.
Smart. And that helps keep the data set manageable too, right?
Yeah, exactly.
So they're really going to great lengths to make this data set as efficient and informative as possible.
They are. And to top it all off, they use OCR, optical character recognition, to extract all the text, symbols, and formulas that are displayed on screen. It's like automatically transcribing every equation from a physics lecture.
Okay, so no detail is too small for that.
Nope, they're covering all their bases.
I'm impressed.
Okay.
So all of that, the keyframes, the transcripts, the on-screen text, it all comes together to create the final multimodal textbook.
It does.
So after all that filtering and processing, how big is this data set?
Well, it's still massive. We're talking 6.5 million keyframes.
Wow.
And 0.75 billion text tokens.
Okay, that's mind-boggling even for AI.
It is. And it's all organized into 610,000 interleave samples.
What's an interleave sample?
So each sample has an average of 10 images and over 1,200 words.
Okay.
It's like a little mini lesson.
Interesting. So the big question is, does all this work actually lead to better learning for the VLMs?
Well, that is the million-dollar question. And the short answer is yes. VLMs trained on this multimodal textbook, they really outperform models trained on traditional data sets.
Okay, this is where it gets exciting for me. Tell me more about those results.
Well, the improvements are especially noticeable in tasks that require like deep understanding and reasoning.
Okay.
So things like answering complex science questions or solving math problems.
So we're not just talking about recognizing objects in an image anymore.
No.
We're talking about AI that can actually understand and apply complex knowledge.
Exactly. They're showing a much deeper level of comprehension than we've seen before.
Oh, wow. That's impressive. I bet you have a specific example.
I do, actually.
Oh, wow.
They came up with this really clever experiment called the cheat test.
Cheat test. Okay, what is that?
So imagine you're giving a VLM a few-shot learning task.
Yeah.
Where you provide a few examples and then ask it to answer a similar question.
Right.
In the cheat test, they actually slip the test question itself into the set of examples.
Wait, so they're giving the AI the answer in the examples?
Yeah, it's kind of sneaky.
That is sneaky.
But it's a brilliant way to see if the VLM is actually understanding the relationships in the information or just blindly following patterns. And you know what? The models trained on the multimodal textbook were much better at recognizing this cheat.
Oh, wow.
And they still got the right answer.
So they're not just regurgitating information, they're actually getting...
Exactly. It shows how powerful learning from interleaved information can be, connecting the dots between the visuals and the text.
That's pretty amazing. It sounds like they're figuring out how to teach AI to think more like humans.
Yeah, it's definitely a big step in that direction. And this opens up all sorts of possibilities for what VLMs might be capable of doing in the future.
This has definitely piqued my curiosity.
Yeah.
What kind of possibilities are we talking about here?
I mean, imagine an AI that can not only understand images and text, but it can reason through complex scientific problems, design experiments, even potentially discover new knowledge.
Hold on, are we talking like AI scientists now?
It might sound far-fetched, but it's not as crazy as it seems. Think about medical diagnosis, for example.
Okay.
A VLM trained on this kind of data could analyze medical images, patient records, research papers all at once, and potentially uncover insights that even human doctors might miss.
Wow, that's incredible. What about education? Could this kind of AI be used to, tutor students in a more personalized way?
Oh, absolutely. Imagine a virtual tutor that adapts to your individual learning style, explains concepts using visuals and examples that are tailored to you,
Okay.
gives you real-time feedback on your progress. It could completely revolutionize the way we learn.
Now, I'm picturing a future where AI isn't just, replacing jobs, but is actually helping us learn and solve problems in ways we never thought possible.
Right. It's a pretty exciting prospect.
It really is.
Yeah.
And it all starts with data sets like this multimodal textbook, pushing the boundaries of what AI can learn.
Yeah, this research is a real game changer.
It makes you wonder why nobody thought of this sooner. I mean, using instructional videos as training data seems so obvious now.
Well, it's not just as easy as, downloading a bunch of videos and feeding them to an AI.
Right.
There's a lot of thought that went into filtering and processing the data to make sure it's high quality and relevant.
Right, like that multi-level filtering process we talked about.
Exactly. They had to be very selective.
Yeah, and they had to figure out how to structure the data for training too, right?
Yeah, exactly. Should they treat each video as a separate sample or break them down into smaller chunks?
Interesting. What did they end up doing?
So they experimented with different approaches, and they found that concatenating multiple video clips together up to the maximum context length the VLMs could handle worked the best.
So they're creating these like mini lessons.
Yeah, each one focusing on a specific concept or knowledge point.
Gotcha. And how do they avoid confusing the AI when they're mixing clips from different videos?
So to signal the transition to a new topic, they insert a special end of video token.
Oh, that's smart. It's like adding chapter breaks in a textbook.
Exactly.
Yeah.
All about that organization and flow.
So all this effort they put into curating and structuring this data, what does it tell us about how VLMs learn best?
Well, I think one of the most important takeaways is that VLMs, like humans, they benefit from a structured and coherent learning experience.
So it's not enough to just, throw a bunch of random data at them.
No, definitely not.
Okay.
They need context. They need to see the relationships between different pieces of information.
Mhm.
You need a storyline.
A storyline. Okay.
And that's what this multimodal textbook provides.
So they're not just learning facts, they're learning how to learn.
Exactly. They're developing a deeper understanding of how information is organized, how it's all connected.
And that allows them to apply that knowledge in new ways.
Precisely. It's not just about memorization. It's about developing true understanding.
That's fascinating. So where do we go from here? What are the next steps in this research? What are you most excited about?
Well, the authors acknowledge that the current data set does have some limitations.
Sure. Like there might be some redundant keyframes or text that could be further refined.
Okay.
And they plan to keep improving the quality and the knowledge density of their textbook.
Right. Even with all that filtering, I imagine it's pretty much impossible to create a perfectly clean data set.
Yeah, that's true. But what's really exciting is that this research has sparked a lot of interest in the AI community. I think we're just scratching the surface of what's possible with this approach.
I can't wait to see what they come up with next. What new types of multimodal data sets will they create? What new problems will they tackle with this approach? It's a really exciting time to be following this field.
It is. This research has opened up a whole new avenue for VLM training, and I think we're going to see some really remarkable advancements in the years to come.
Well, on that note of boundless potential, I think we've reached the end of our deep dive. But as always, the learning doesn't stop here. What final thoughts would you like to leave our listener with today?
I think it's important to remember that this research isn't just about improving benchmarks or creating, those impressive demos that we see.
Right.
It's about fundamentally changing the way we think about AI and its potential.
Yeah, I think that's a great point.
Yeah.
We often get so caught up in the technical details that we lose sight of the bigger picture.
It's easy to do.
It is. So what does this research tell us about the future of AI?
Well, it suggests that we're moving beyond the era of AI that just, recognizes patterns or generates text. We're entering a new phase where AI can truly understand and reason about the world around it, much like humans do.
And that all comes from this idea of teaching AI using the same principles that we use to teach humans.
Right, exactly. The multimodal textbook is a perfect example of that.
Yeah.
It's designed to provide AI with that same kind of rich, structured, engaging learning experience that we would give to a human student.
Okay, need a concrete example here.
Yeah.
So let's say we're looking at a sample from the Earth Science section of the textbook. What would that look like?
All right, so imagine a sequence of keyframes showing diagrams and real-world footage of the water cycle.
Okay, I can picture that. What kind of text would accompany those visuals?
So you'd have the transcript of the instructor explaining the different stages of the cycle, evaporation, condensation, precipitation, runoff,
Right.
and how they all connect to form this continuous process.
And the OCR would be capturing any labels or definitions displayed on screen?
Exactly. So the AI is getting this multi-layered understanding of the water cycle. It's not just seeing the visuals or hearing the words in isolation. It's learning how they all work together to create that complete picture.
It's like having a dynamic interactive textbook come to life.
Exactly. And that's what makes this data set so effective. It's not just about presenting information.
Right.
It's about presenting in a way that's natural, engaging, and conducive to learning.
It replicates the way humans learn best.
Exactly.
Okay, yeah. I can see why VLMs trained on this data perform so well on those reasoning tasks. They're learning to think about concepts in a more holistic and interconnected way.
Yes, exactly. And it's not just limited to earth science either. We see similar results across all the different subjects.
Oh, interesting.
Like, let's take physics, for example. Imagine a video clip demonstrating the concept of velocity.
Okay, I'm picturing a ball rolling down a ramp.
Right. The instructor might be explaining the formula for velocity, distance over time,
Right.
while pointing to the ball's movement on the screen.
And the OCR is capturing that formula along with any labels or units of measurement.
Exactly. So the VLM is learning to connect this abstract concept of velocity with a visual representation of motion and the mathematical formula that quantifies it.
Wow, so it's getting a complete picture of the concept from multiple angles.
Yes. And the more examples the VLM sees across different subjects and domains, the better it gets at making these connections and understanding the underlying principles.
This is truly groundbreaking work. It feels like we're on the cusp of something really big here.
I agree. And what's even more exciting is that we're just getting started.
Yeah.
Imagine the possibilities when we apply this approach to even larger and more diverse data sets across even more fields of knowledge.
Yeah, the potential is really limitless. We could see AI systems that can help us solve some of the world's biggest problems,
Absolutely.
from climate change to disease.
And it all starts with this fundamental shift in how we think about AI training. It's about moving beyond simple pattern recognition towards genuine understanding.
Well, on that inspiring note, I think we've reached the end of our deep dive into this fascinating new approach to training VLMs.
Thanks for joining us.
Big thanks to our expert for sharing their insights with us today, and of course to all of you for listening.
And remember,
The learning doesn't stop here.
we encourage you to explore this research further and think about the questions it raises.
What other ways can we teach AI to understand the world like humans do?
What new possibilities will this unlock for the future?
What breakthroughs in science, medicine, education might we achieve with AI that can truly learn and reason?
We'll leave you with those thought-provoking questions to ponder. Until next time.
Thanks again for listening.